Come back again to these classes, these lessons. So we have been having lessons on effects of heat on substances. Then remember, we begin by looking at the type of changes that substances undergoes when subjected to various conditions of temperature, or when these substances are subjected to heat. Now we looked at the two types of changes initially in the beginning of these lessons. We looked at a temporary change and a permanent change. Now, we had already talked about a temporary change, so we are winding up. We are finalizing the effects of heat on substances with a permanent chemical change. So we talked about a temporary change, and just a quick review of what we talked about, right? So under a temporary change, we mentioned that we have two types of changes, and these are a temporary physical change and a temporary chemical change. And we had adequate time to demonstrate a temporary physical change and a temporary chemical change using various substances which we have in nature. Now, allow me to introduce to you a permanent chemical change. As the name suggests, permanent chemical change. This is a change that happens permanently. We cannot be able to reverse this type of change. It happens permanently. So this is what we are going to talk about today. But before diving deeper into a permanent chemical change, as my custom or my culture, allow me to take you to the summary section. The summary means what we are going to discuss as far as permanent chemical change is concerned. So in our summary section, the key point to know by the end of this lesson, we need to understand or define what is a permanent chemical change. After understanding or after defining what is a permanent chemical change, we will also need to understand some of the substances in nature which we can use to demonstrate a permanent chemical change. So the substances which we can use to demonstrate a permanent chemical change. Now, after demonstrating a permanent chemical change using different substances in nature, we will required to write word equations using these substances that demonstrates a permanent chemical change. So we will have time to write word equations. Then the final part of it, we'll talk about the characteristics of a permanent chemical change. Characteristics of a permanent chemical change. Remember, for each change has a unique characteristics. Now, for this also, for permanent chemical change, it has its own characteristics that are able to tell us that this type of a change is a permanent one, is a permanent chemical change. Then the last one, the last in our list of summary or in our summary section, we'll talk about examples of chemical changes in real life, in daily life. Now, allow me to take you through what we have in the summary section. So a permanent chemical change, as the name suggests, this is a change or changes that happens permanently, right? We cannot be able to reverse this type of change when they happen in nature. So they happen in a long last. They last long. We are going to live with these changes forever in our life, in the entire life. They happen permanently. Okay? Now, let me begin with the second objective here, or the second summary. What are the sum of the substances in nature or in environment or in our daily life which can be used to demonstrate a permanent chemical change? What are the sum of the substances which we can use to demonstrate a permanent chemical change? For our case here, we are only going to use two substances. And these are the first substance, we're going to use copper 2 nitrate, copper 2 nitrate. For our case, we are going to use two substances, and the first one is copper 2 nitrate. Then the second one is potassium. The second one is potassium permanganate. Permanganate. Potassium permanganate is also called potassium manganate. Manganate 7. Now, these are the two substances which we are going to use to demonstrate a permanent chemical change. The first one is copper 2 nitrate, this one here. Then the second one is potassium permanganate. The other name for potassium permanganate is potassium manganate 7. So in an exam case, whenever you get a potassium permanganate, don't confuse yourself. Potassium permanganate is the same as potassium manganate 7. Now these are the two substances we are going to use to demonstrate a permanent chemical change. Right? Now this is what we are going to do in this case. We are going to heat these substances, these two substances, and observe what is going to happen when we subject these two substances in heat. Right? So I want us to see. Let's begin with the first one. What happens when you heat copper 2 nitrate? What happens when you heat copper 2 nitrates? What happens? What happens when copper 2, let me write in full, copper 2 nitrate is heated? This is the key point, what you need to ask yourself. What happens when copper 2 nitrate is heated? This here. What happens when copper 2 nitrate is heated? Now, it is very common. Copper 2 nitrate is a solid substance which is blue in color. So the color of copper 2 nitrate is blue. This blue in color. Then you also need to know that copper 2 nitrate is a compound. How do we define a compound? A compound is a pure substance made up of two or more elements chemically combined. Is a pure substance made up of two or more elements chemically combined. So copper 2 nitrate, this one, is a compound. It's made up of various elements. If we can just take the short time to examine what are the components, the elements that are there in copper 2 nitrate, we'll get that we have copper, then we have nitrogen, Then remember I said where we have AET, that is oxygen. So copper 2 nitrate has 3 elements in it. It has nitrogen, it has copper, then it also has oxygen. Now what happens when you heat copper 2 nitrate? Simple. When you heat copper 2 nitrate, it breaks down or it decomposes. Decomposes means it breaks down, right? So we can write here, let me use a different pen. When you heat copper 2, it breaks down. It breaks down. It breaks down to form. It breaks down to form. Three. It breaks down to form 3 substances. It breaks down to form 3 substances. I want to take you back. When you heat copper 2 nitrate, it breaks down to form 3 substances. And these 3 substances are, the first one is copper 2 oxide. Then B, the second substance which is formed after the breakdown of copper 2 nitrate, we have nitrogen 4 oxide. Nitrogen 4 oxide, this is a gas. Then C, oxygen gas. Oxygen gas. Those are the 3 substances that are formed after the breakdown of copper 2 nitrate by heat. Now, what is so important here is to understand the color of these substances. Now, the color of copper 2 oxide is black. Black in color. Then the color of a nitrogen 4 oxide gas is red brown. Then the color of oxygen gas is colorless. That is what is so important when it comes to copper 2 nitrate, heating copper 2 nitrate. You need to understand the substances that are formed after the breakdown of copper 2 nitrate and the color of those substances, right? Now, when you heat copper 2 nitrate, it breaks down to form a black substance, copper 2 oxide, which is black in color, and nitrogen 4 oxide, which is a gas, and the color of this gas is red brown. Then it also forms a colorless gas, which is oxygen. Now, when you strongly heat copper 2 nitrate, it forms 3 substances here. The first one is copper oxide, which is black in color. Then the second one is nitrogen 4 oxide, which is red brown. Then the third one is oxygen gas, which is colorless. These are must, you must know. It is key as far as exam is concerned. Now, we can write the word equation to represent this. The word equation. So the word equation, my pens are not writing. Word equation. So word equation, let me use a different pen. So we begin by copper 2. Copper 2 nitrate. Then you indicate an arrow here. Then on top of arrow you indicate heating. Heat. Just there, place there heat. Then we get copper copper oxide, get copper 2 oxide. Then we also get plus we get nitrogen 4 oxide, nitrogen 4 oxide plus oxygen. When writing word equation, you need to indicate the color of these substances. You need to indicate the color of copper 2 nitrate. Then you also need to indicate the color of copper 2 oxide. Then also indicate the color of nitrogen 4 oxide and the color of oxygen. That's how we write the word equation when we are heating copper 2 nitrate. So the color of copper 2 nitrate is blue. Then the color of copper 2 oxide is black. Then the color of nitrogen 4 oxide is red brown. Then the color of oxygen is colorless. Right? So we are done writing the word equation. And remember, when you are writing the word equation, please indicate the color of these substances. For instance, copper 2 nitrate is blue in color. Copper 2 oxide is black in color. Then also nitrogen 4 oxide is red brown in color. Then oxygen is colorless. Right. The reason why I'm saying it is so important to indicate the color of these substances, examiner might be tempted to trick the question. For instance, if you get a question like this in an exam, a grade 8 learner heated a blue substance in the laboratory. Heated a blue substance in the laboratory. Then this blue substance breaks down to form a black substance, and the red-brown fumes were observed, and also the colorless fumes were observed. Then question A, part A of that question, give the identity of a blue substance. The identity of a blue substance here which was heated is copper 2 nitrate. Then the black residue that was obtained after heating is copper 2 oxide. Then the red-brown gas that evolved during heating is nitrogen 4 oxide. Then the colorless gas produced during heating is a colorless gas. So in as much as we are trying to discuss about these, we need to understand the language of examiner. Now, how can we understand the language of examiner? Write your word equation, understand the color of these substances, understand the color of the products formed after heating copper 2 nitrate, then try to figure out the possible questions that are likely to come out of this equation. Right. Now, we have written the word equation for copper 2 nitrate when we are heating copper 2 nitrate. Then in the next lesson, we are going to write the word equation for potassium permanganate. The word equations when we are heating potassium permanganate to demonstrate a permanent chemical change. Thank you very much. Thank you for your time.